Well, so welcome to this week's episode of Starting Pixel. I think we're up to like number 23, which is quite exciting. So just to remind everyone, Starting Pixel is a podcast. It's all about technology in content creation, I guess, and entertainment. So that covers all things from film and live events, as well as social media, as well as broadcast TV, all sorts of things. But it sort of comes from the angle that this new all these new technologies coming into it, really helping storytellers tell all their stories in different ways as well. And today's guest, I'm so excited that we got Christopher Nichols. Is that best? I'm really great at getting the pronunciation of people's second names wrong.
Nichols is a fairly common Anglo-Saxon name, so I think you nailed that one fine.
Okay, right. No, you'll be surprised. I'm quite good at getting Anglo-Saxon names wrong. That's for sure. And Christopher, are you a Chris or are you Christopher?
I'm whatever you want to be. Chris is fine.
I'm fine, and I'm more than happy to call you your preferred name. So who was I talking to the other day? And they said, "Oh, well, yeah, nobody never asks me how I'd like my name to be pronounced." I think it was a Victoria. I said, "No, is it really important that you get called the name that you want to be called?" So anyway, so thanks for joining. That's the big opening question as well. And apologies again for being particularly tardy. How about first of all, you tell us a little bit about Christopher Nichols and what you're up to doing. And I always like to first start the first bit off, certainly with the first interview as well, is actually sort of your journey in a few, 5-10 minutes from wherever you want to start to wherever you want to finish.
Okay, that's a long story. Well, I've
That's
been
kind.
doing visual effects for a long time, but actually my career really started my first career in in CG really started in architecture back, and that's why I went to architecture school. I got my master's from Rice University, and that sort of really created this interest in computer graphics. Back then, there were not many options, but there were very, very high end graphics in order to get into it. And I was lucky enough that Rice University had SGIs and big high end PCs and all these things to make that happen. So I sort of jumped into it. But to be honest, the architecture community didn't even know what to do with the SGIs. They were sort of using them to write their emails. I mean, they were
You
kind
know
of hard.
what?
But
Yeah. I was just going to say, actually, I've not heard the term SGIs for ages because I used to use them in the 90s as well. And it's like Silicon Graphics.
Mhm.
What happened to Silicon Graphics? They were the best things.
Well, they
And it's
went
like, yeah,
bankrupt.
right.
There's an entire story about it. If you actually want to
I'm
listen to
sure.
Scott Ross's book or his audiobook about it, it's really pretty interesting. But I sort of got into it at that point in architecture, and I became sort of a big thing about visualization. I joined Gensler Architecture at the time. It was still to this day the largest architecture firm in the world, and I really got involved in the graphics things. But what got me, it sort of eventually led me to go into film, right? I sort of became much more interested in the idea of graphics, and I didn't really care necessarily about seeing buildings being built. It's something I didn't really realize until way after I became an architect, which was kind of ironic in a way. But
Yeah.
I
Happens.
really sort of love the story of making images and telling stories, and that became sort of an important part of what I did. I ended up getting a job at Digital Domain. I worked at Digital Domain, and then it sort of bounced around all kinds of places for a long time. Did many feature films, and really focused a great deal of my attention around the world of lighting because that was something that became sort of really interested in, especially when it came to high end rendering. At that time, ray tracing was not something that was a big or well used in graphics in the early 2000s because it was quote unquote too expensive to do. So people would hack their way through trying to
Right.
fake ray tracing forever in order to let's do something that looks like global illumination, but is not actually global illumination. They would do things like ambient occlusion or whatever they could hack to make things work. And I became sort of like, well, why, if we're doing that, why don't we just ray trace it and be done with it? That was sort of my mentality at the time. They're like, no. We need to do all these complicated things, right? They invented things like brick maps in RenderMan or all these different hacks and caches in order to try to mimic what was possible with ray tracing. And I was just sort of much more interested in like, well, why don't we just ray trace it? And ray tracing became kind of this big deal for me. And sort of one of the big people that sort of was always helping me out in terms of ray tracing was actually Vlado, who's my boss now. But at the time, I knew him as the guy who one of the guys who invented V-Ray. He's in fact the V in V-Ray. And I was one of the very, very first customers of V-Ray back in 2001, in fact, when I was still at Gensler, and sort of watched it evolve. And in a lot of ways, so essentially, I sort of followed a lot of things in terms of ray tracing and where that was going. And I was one of the people sort of tried to say, hey, let's try ray tracing instead of doing all of these hacks. This was around, like I said, early 2000, 2006 or so. And it just became sort of a thing that I became very interested in. And eventually that became the truth, right? What ended up happening is that everyone eventually said, well, let's dump these hacks that are very, very interesting and complicated and all these things. But really, if you just ray trace them, you don't need to do any of them, right? And that sort of became the sort of the where vendors like V-Ray and Arnold really were shining at the time. And that became sort of the 1-2 on that. And that eventually led to both of those vendors, both V-Ray and Arnold, winning an Academy Award for their work. And I think it was in 2017 is that they got the SciTech Award for what they were doing. So it's something that I became very, very interested in. And around 2013, it was an interesting time in visual effects, and it was a tremendous. What's the word? It was a tremendous, or what's the word I'm looking for?
Yeah.
Hard time, hard to
Yeah, whole time.
tumultuous,
There you go.
tumultuous. That's the word I'm looking for. It's a word salad time. It was, and I call it the life of Pi days, right? When they didn't really know what was going on, companies were going bankrupt, and the studios were treating visual effects companies really, really poorly. And forcing them into bankruptcy. And the other big thing that was happening around that time is that basically, even though, all the studios and all the executives were based in Los Angeles, they were forcing everyone to go to all these tax subsidy places to do whatever they did. And I didn't feel that I didn't want to be able to be forced to move to chase tax subsidies around the world and have to move my family around. So
Yes.
I decided, instead of worrying about doing production, maybe there's something else I could focus on. Luckily, I ended up getting a job at Chaos. Like I said, I've been very close friends with Vlado and Peter over the years, and they offered me a position to work on some stuff here, and it quickly sort of evolved into a position into what we called Chaos Labs, and it's now sort of evolved into what they call the Chaos Innovation Labs. When I starting there, it was sort of like, well, what can we do? What are some interesting things? And one of the very first projects I worked on was from one of our customers, or a user more specifically. But he was a director and a VFX supervisor from Blur, and he wanted to do his own passion project on something, and we had strong relationships with him, both with Blur and with Kevin Margot. Kevin Margot was the guy, by the way, and he wanted to create this short film, and I wanted to use some licenses of V-Ray, as a lot of people do. They're like, oh, can I get some free licenses of your software to do my short film? And that happens quite a bit. And honestly speaking, those are great opportunities, right? It's not just people that want free software. It's opportunities to look at what's new. And so when you get projects like that, if you work in a software area, you sort of look at what you're doing in development, what's being worked on, and seeing if there's an opportunity for that project to be a test bed for that new technology. And we had been working on GPU rendering for quite a bit in terms of ray tracing, right? Ray tracing was just a computational thing that took a lot of time, but then GPUs came along, and we actually created the first GPU version of V-Ray back in 2008. But in 2013, the thing that was interesting was that NVIDIA had come up with these brand new GPUs that had 12 gigs of video memory, which was much more than anything else that ever happened at the time. And they were the K6000s. And so at that point, we started looking at, well, GPU rendering was because they had such little memory, and you have to use only the GPU memory. You couldn't really do final frame rendering on a GPU until they got to 12 gigs. And so we looked at Kevin and said, hey, do you want to do all of your short on a GPU? And if you do that, we'll see if we can get other sponsors. And we got NVIDIA to sponsor, and we got a Box Computers to sponsor, and they gave a bunch of hardware to Kevin to sort of do this. And it became like, the first short rendered as full ray trace on the GPU. And it wasn't real time, or at least that wasn't the plan to be real time, right? But what we found out is, NVIDIA was very generous. I'll just put it that way. They gave us like $50,000 worth of GPUs to just throw at the problem, right? And I was like, oh, wow, right? And then we needed multiple computers because that's a lot of GPUs to put in there. So we got Box to go all these computers. And what Kevin figured out is that, you can add more GPUs and the render just speeds up like exponentially for what we were doing, to the point where he's like, let's throw 4 GPUs into a computer And back then you didn't have, GPUs didn't take up 600 watts like they do today, but
Right.
uh,
Yeah.
but they did. But we started saying, it's like, oh, if I throw in enough GPUs at this thing, we can see the rendering is almost real time, very noisy and real time, right? And so we started to think about, like, well, what does this mean? And because, Kevin's background from Blur, they do a bunch of their performance, they do as performance capture with motion capture performance, right? And so the short film he was going to motion capture, it was a story about robots, and it was you can look it up, the old Construct short, but they were motion capturing these guys, these robots sort of and they had a big fight sequence and all this other stuff. And I was like, what if we could motion capture these robots and ray trace them instead, right? And this is back again in 2013. And so we developed a version of V-Ray using something that was also new called the V-Ray App SDK. We developed V-Ray to run inside of Motion Builder. And so when we do that, you start thinking about, well, we're replacing the crappy gray shaded OpenGL rendering of Motion Builder with full ray tracing. And it's sort of changed the entire paradigm for us. So like, oh, wow, this completely changes the way we think about everything. And we started realizing that instead of just looking at something as like, well, I can imagine what it's going to look like when it's fully lit. No, we could fully light things. We could get it, it was, like I said, it was grainy, et cetera, but we could start to see I saw the future, right? I started seeing what was going on.
Brilliant.
I was like, this is where suddenly the cinematographer can do their job in digitally instead of just relying on the technicians to do it. And then the cinematographer comes in. I guess that's what it's going to look like.
Yeah.
And that was, and the director too, right? Everyone could see it, or at least where it was going to be in terms of the final frame, because what we were rendering in Motion Builder was going to turn into the final frame, right? And we could see it happening at the same time. Again, like I said, noisy. And we experimented with it. It's like, okay, well, can we make it higher resolution? Can we make it less grainy? And we even did an experiment where we were lucky enough to get access to one of the clusters of GPUs. I think this was in 2014 or so, at the NVIDIA campus. And we rendered on 32 GPUs all at once to see how much higher resolution we could get and how much cleaner we could do. And at that point, we got one that was, I won't say noise free, but it was significantly better. And it was half HD, as 960 by 540. And it looked pretty good. It looked really great. But this was all through the cloud. It was just this total, like bubblegum and duct tape scenario that we did. But it was pretty impressive programming that we figured out how to make this work. Again, I was seeing the future in this, and I was fascinated by it. And I became obsessed with the idea of real-time ray tracing, not just ray tracing added on like we were doing again back in the early 2000s, but they're like adding some ray trace shadows or whatever to try to make things look good. I'm talking about full ray tracing, full global illumination, full everything. And when you do that and you completely abandon the rasterization, you sort of open a new paradigm of what was going on. And I was sort of just following this. Like we work very, very closely with NVIDIA. We're seeing how the GPUs were progressing over years. And 2018, NVIDIA came up with a new GPU, which was, if you're looking at numbers, it was basically what turned into the 2080 GPU. And it was the first GPU to incorporate ray tracing cores into their system.
Right.
And these were RT cores. And so because NVIDIA knew what we were doing with GPUs and how much we used our ray tracing on the GPU, they gave us early access to the API, sort of started exploring that. And we ended up developing, because we knew exactly what we were doing with those GPUs and how we could use it. As a side project, it's like, well, let's make a renderer specifically for real time. Not try to just improve V-Ray. Let's let V-Ray be V-Ray to do all these new features, but just focus on the real-time aspects of ray tracing. And that became the early versions of what now is Vantage. And we called it Project Lavina at the time. And it became sort of this thing. We realized that these GPUs could ray trace really, really fast. They couldn't necessarily do super complicated shading, but they could trace a ray faster than anything we'd ever seen before. And that sort of enabled us to look at, what I was seeing on those 32 GPUs in a cluster, I could see on a single GPU on a laptop. And it was a massive jump in speed.
Right.
And it was kind of groundbreaking, And then again, like I said, that was 2018. And then around 2019 to 2020, during the pandemic, we started seeing this interest in virtual production again, right? Became a big deal, as I'm sure you're aware. And, that's when suddenly we saw the game engines coming in. And that was a very interesting idea, because really, motion builder was the only thing that people had to do any kind of idea of virtual production. It was really the only thing they had. And it was virtual production was only in camera stuff. And so uh, it was not, it was no LED screens or no in-camera VFX, right? It was just basically virtualizing a camera through a viewport. But then when the game engines came in and it's like, no, we can significantly improve the real-time rendering, and they were right. It's especially compared to motion builder. They sort of really took over the space, and it became a big splash, right? Everyone started thinking about it, and then eventually this turned into the LED walls, as you're well aware, and then became in-camera VFX, and it became this big thing. And I was like, well, this is it. Let's get into this, right? And that became a big pressure or a big interest of mine for the labs. And Vlado started becoming interested as well, saying, well, let's look into this. But the problem was we were still, when we're doing full ray tracing, still couldn't quite get the noise-free thing that we were looking for at the resolution that was necessary for an LED wall. Then, but 2023 came along, and NVIDIA continued to innovate on their GPUs. And they had developed in their drivers, as part of something they were doing, is a new evolution of their DLSS, and DLSS 3.5 was what came out in 2023. It incorporated a new kind of denoising called ray reconstruction, which was denoising specifically done for ray tracers. And because of the way that we had been writing our render, we were able to incorporate that part into our render. Pretty much just turned it on, is the catalyst. That's really when we say then everything fell into place, and we could get the high quality rendering at the speed that we needed to do in-camera VFX. And my feeling was, perfect. Well, then all we need to do is put Vantage inside of Unreal. Right. And that was my thing, is if we put it inside of Unreal, then we'll get all the full ray tracing and we'll get all the benefits of the virtual production. And Vlado's question is like, well, let me ask you this. It's like, what's necessary for us to, what's the minimum viable product that we need to be able to get something on an LED wall? Well, like, what do you need? And he's like, well, there's several things that are necessary to make that happen. One is most LED walls will operate on multiple nodes. As you guys know, you divide the wall into multiple sections, and each one is run by a separate computer. And then those computers are synced up through a QuadroSync card. And that's the first step, right? So, and then the second thing that is necessary is to track the camera, as we know. And then that camera gets tracked the way we did it back in the Construct days. And then we render out the frustum of that camera. Yeah. And so Vlad's like, well, instead of going through the game engine, why don't we just make that instead? Just do those two things on our own in the lab, and then we can just sort of bypass the game engine. And I was like, okay, well, let's try that. And so we did that. We just did a very basic version of that. And I started to realize, like, well, hold on a second. If we bypass the game engine completely, this means that essentially people can just go from their 3D application to an LED wall in like 10 minutes, as opposed to having to involve massive translations of data, converting data, making shaders work, adding all this stuff to make it look like the final frame. And so that became the catalyst for what Arena ended up becoming. And so, yeah, that was our big breakthrough in 2023. And then that led to us sort of continuing to develop that. And then Vlado said, well, let's make a short film to sort of test it out. And we did a short film called Ray Tracing for the Win. That came out in 2024. And since then, it's continued to evolve quite a bit. In fact, we're coming up on SIGGRAPH, and we're about to make some big announcements about a lot of the new things that have been added to Arena and Vantage at this point. So super exciting that it's our big thing. Full ray tracing is kind of the game changer for us, and I think for the industry in a lot of ways.
Yeah, absolutely. I tell you what, so for some people who watch this, you've mentioned the word ray tracing an awful lot. Please, for explaining to your grandmother or me, how do you explain ray tracing?
Sure. Well, ray tracing is actually the simplest. If you think about it, it's the simplest, most logical way to simulate lighting on a computer. right? It is actually one of the first ways that people did rendering. And essentially what it is there's rays of light that you calculate when you are in a real space, whatever, and you turn on a light bulb. There's light comes from that light bulb and emits energy out in a space. What happens after that energy hits a surface is that it reflects back, and it can reflect back in many different ways. If it's a mirror, obviously it reflects back very linearly. But if it's a diffuse surface, it scatters light and goes out. And that's what's called global illumination. So it's really about shooting millions and millions and millions, or more like billions or trillions of rays every second, and then imitating the way that light falls out in space. And once you've done that, you've solved all lighting. You don't have to worry about anything else. But the problem with it is because you have to calculate so many vectors, it becomes very computationally expensive, right? And that's what I meant by, like back in the old days in 2000, when you did, no one wanted to involve ray tracing because your renders would go from like an hour frame to 12, 24, 30, 48 hours a frame just because you're doing ray tracing, right? So it was a very quote unquote expensive, meaning how much time it used on the computer to get it done. So people ignored it until things got faster and faster, both with the hardware and with the software being much, much smarter. There's things called ray tracing acceleration algorithms that allow it to be much faster. Rasterized rendering, which was the alternative to doing ray tracing, which is what's used mostly still used a lot in a lot of real-time solutions, such as video games, is a way to fake lighting that does it a little bit differently. You fake the way that lighting works on things, but it can do it much, much faster than a ray tracer can. But there's a lot of tricks you can do to rasterized rendering to make it look like ray tracing. Right, you can add things like different caches. You can sort of create different ideas in terms of how light bounces around. You can do just a little bit of ray tracing to try to get it the feeling of ray tracing without using full ray tracing, right? So like the trick they used to do in the old days is you add something called ambient occlusion to make it look like the light was kind of bouncing around, but it really wasn't the real lighting. It was just a fake way of looking at things.
Right.
Or even like, let's, like for example, right now, an example that people might know if they're using game engines or Unreal, for example, Lumens, right? Lumens isn't really ray tracing, but it's faking the way ray tracing works and does this caching system to make it look like it's ray trace. And it's kind of ray trace, but it's not really ray tracing, right? It's not really that way. Or another thing that ray tracing can do, because of the way that rasterization works, because of the way that the ray tracing accelerator works, you can actually throw a huge amounts of geometry at ray tracing without it affecting performance. Rasterization, you have to optimize your geometry constantly to do that, right? So the way that the game engines come around that, they use something like, a system that's in Unreal is something called Nanite, right? Allows you to sort of cache your geometry. And it works. You can do more geometry that way, but it's a sacrifice in order to make that work. With ray tracing, I don't care. I throw in all the geometry. And ray tracing for the win. We had a scene that had 2.8 trillion polygons. Didn't matter, right? Never affected the performance, right? So, and that's sort of the thing, right? You kind of have to think differently when you're doing full ray tracing. Your problems, you don't have to sit here and optimize and optimize and optimize and optimize, which you do have to do if you're doing a video game. But if you're making a film, you just want to get the highest quality possible on your screen. And that's sort of, one of the things that ray tracing offers. Like I said, if you're able to ray trace it, you're done. Problem solved. You don't have to worry about all the other problems.
So so I guess ray tracing is complicated. So you effectively I guess you're asking the computer to literally calculate, right?
It's actually very simple. It's just a lot of computation.
Yeah, it's like send thing to this calculation. When it hits a thing,
right,
it then does a sort of action. It bounces or it causes some, but you just have to do that for every single photon or sort of virtual photon.
Well, there's two ways to look at it. You can think of the light coming from the actual light sources, and you can think of the reverse of that, where the light that's absorbed by the camera. So you trace from the camera out, or you trace from the lights in, and that's called bidirectional path tracing.
Right.
So
yeah, and then of course, so you've got that, and that's fine. That's complicated enough. And then suddenly someone decides to dim the light, or move a light, or the cloud goes in front of the sun, or something like that. And then you have to then do that for every single frame. So if you're shooting 24 frames a second, it's
Yep.
like,
And we can do that, right? When now with because of the speed of these ray tracers and the GPUs that are going on in real time, we do that in real time, right? So we can
yeah,
change the light, we can move the light, we can do all kinds of stuff. And it's so freaking fast now. It's kind of mind blowing, right? The amount of rays that we can shoot now with these new GPUs is absolutely mind blowing. I mean, not just like massive leaps, right? And then you add these new AI denoisers and it's even better. It's like a crazy, crazy good. But you really
and
think of
again,
it, it's so much closer to an analog of a film or a digital camera, right? The lower the light, meaning the less photons you shoot or the
yeah,
less
yeah,
rays you do, the noisier your image is, like your film is or your camera is, right?
interesting, right?
Right? It's very, very similar, right? And the computation that's now made these things really good is kind of incredible. Look at your phone. Your phone's got a sensor that's like so freaking small, yet somehow we get these incredible images out of it. That's
Yeah,
because of all the computation that makes that image so good, right? And the same thing is happening with our in our virtual world. We're creating incredible images. If I turned off the denoiser in Vantage today, you'd see just a garbled noise mess, but the AI is so good at filling in the rest of the data that it's kind of like we just give it
right,
just enough rays. And then the AI is like, I know enough to fill in the rest of the rays.
right. Yes, that's amazing. Yeah, wow. Yeah, as you were sort of saying this and taking us back to the sort of the silicon graphics PCs and, Moore's law and all this kind of stuff where, I mean, and you'll remember, turning on a PC, like a normal desktop PC, and then you go off and have a coffee and then you come back and it's still booting up kind of Windows and fast forward 20 to 30 years and, you've got these mobile phones that even if they don't instantly react, you're getting really, really frustrated. And yeah, and the other really interesting. So I've sort of been in this world since the pandemic, really. So
Mm.
my experience was, I guess there were 30s or Titan, and maybe it was the one before. 3090s, and then we were using Unreal Engine 4.26, I think,
Hmm.
remember?
Yep.
And I was thinking to myself, this is all garbage. Why am I doing this? It's like nothing looked quite right and everything looked gamey, and you're sort of leaning into the sort of trying to work out how to make things look more realistic. And that was, I mean, you could still count it in months. I think, it was 5 years ago, and, the pandemic lasted a couple of years and we're outside of that there. But it is blisteringly fast, how that has gone from these GPUs that were pretty good, they were a lot better than, things before, to these things now that it feels like Moore's law has been for GPUs is sort of actually exponentially wrong.
It's
It's like
gotten
it's so much
so
quicker.
fast. It's gotten so fast. But, unfortunately, Moore's law, the laws of physics sort of still apply here, right?
Yeah.
Like,
You can't make
that
things that much smaller.
you can, but then suddenly your GPU needs 600 watts to make it do it, right? So there's a lot of that started happening. But, they are so fast. Go back to the 3090, right? Which was a fantastic GPU, as we established. But that GPU still today, refurbished 3090, still costs $1,000.
Yeah, I've got one in
Right?
my
And that's
PCs.
two
I love it.
generations old.
Yeah. Yeah.
And a 5090, forget about it, right? But it's like it's still a lot of there's so much that you can do with these GPUs. It's just quite astonishing. Yeah. I mean, there's still a lot of very interesting tech that's out there that's continuing to be developed in these
Do,
lines.
do you think they're going to plateau in as much as actually it doesn't? There's only so much. It's a bit like you can't make an Apple uh, MacBook start any quicker. You open it and it's up. The same with the phone. It's like you can't make it any faster. So what's that? Where's that?
I
What
think
is going to happen
it's
as
gonna be a
those
combination. I
things?
mean, there's gonna be a combination of many things. Well, first of all, let's look at the priority of what NVIDIA is doing, right? They are going to continue to develop their ray tracing capabilities on the hardware. But honestly speaking, that's not their priority, and it shouldn't be, right? The reason that NVIDIA is a $4 trillion dollar company is because they're the king of the AI world, right?
Yeah.
Which is fine, because what we noticed, like I mentioned in 2023, wasn't necessarily just the ray tracing that got faster. It was the AI that suddenly enabled the ray tracing to be more efficient. Right?
Right.
And
Yeah.
that's what's sort of evolving. So I think what you see is not necessarily that the Moore's law of how many more cores and how many more CUDA cores or how many more ray tracing cores are added to these GPUs, they're going to continue to go up. But what's more important is how that software gets implemented, right? If someone continues to implement better and better ray tracing algorithms through AI, then it's going to become much more important, right? Things like ray reconstruction sort of changed the trajectory of what real-time ray tracing could do. But at the same time, it's an AI, right? So I'll just give you another example. The very first version of ray reconstruction with 3.5 was incredible when we see it. But what we suddenly noticed is that very fine objects, let's think of like a chain link fence or something like that,
Okay. Yeah.
was
Got it.
getting blurred. And it, like, you couldn't see the detail, even though everything looked perfect. Things with very fine geometry was getting blurred and getting choppy in the denoiser.
Right. Yeah. You start. Yeah. Yeah.
But then they trained their AI on a different way and do model. Again, this is on the innovation and the AI side of things. In DLSS 4, they changed enough that all of a sudden that problem went away and it was clean renders on those geometry. The continued innovation that's going to happen is going to be on the how the AI is trained, or what new algorithms are developed for things. What's the next version of what computation is? So I really believe that the hardware is just going to be there to serve the other parts of the innovation that are happening. They're going to accelerate things.
Right. Yeah. I get it. So I guess, yeah. So what the LLMs are doing, I guess, and correct me, which I'm likely to be wrong, is that it's really helping guess, because you said it's like everything's choppy. If you turned it off, it just visually would look right. But the LLM just knows, is it predicting where a pixel should be and what it should look like? Is that
Well, yeah, it's not an LLM because it's not language. It's a it is definitely machine learning. But what it's doing is essentially, you're right. So it's taking the data that it knows from the ray, and it says, okay, I understand that that ray has this intensity, right? And then it takes other parts of the information as well, because we feed it not just the noisy image, but we also feed it things like the albedo and the normal mass, et cetera. And it takes all that information simultaneously and says, okay, based on this, I'm going to guess that this is what the color should be for all the
yeah.
rest of those pixels and all the rest of those samples. And it does it in a matter of milliseconds, that's the thing that's incredible, right? So then it gives you the clean image from that point of view, right? So other things that are happening, for example, like depth of field, fully ray traced depth of field, not something faked with just Z depth crap that you get, and you get all these weird little edges on things, but real depth of field that's fully ray traced is not quite trained in that system yet, right?
Yet.
So yet again, see, so there's all these opportunities now. Now it's like, okay, now we've trained it on this. Now let's train it on depth of field. Let's train it on this and train it on that. And suddenly you get these motion blur, right? Fully ray traced motion blur as opposed to 2D motion blur is significantly better specifically under some of these conditions. And train it on motion blur. Motion blur means you have to have samples every between frames. So it
Yeah.
gets much
Right.
more complicated, right? So how do you train that system, and what can you do? And that all comes from just some amazing, brilliant developers that are thinking about what to train these systems on, and or what the next problem is.
Where do you see it? Sort of, where would you see it going? Are we going to get to like is this almost perfection? Like, any progress is going to be hard to see? Or
I don't know, but I'll tell you this. I can't predict the future. I can only look at the past and see how I can predict the future based on what I've seen in the past. Right? Here's the thing. I mentioned, back in 2006, when everyone was trying to shoehorn all of these different systems into rasterized rendering to try to make them look like ray tracing, right? And the best example I have is WALL-E, the movie WALL-E. Okay. If you look at WALL-E, one of the biggest problems that were before WALL-E, one of the biggest problems that was with rasterized rendering, that was RenderMan at the time was still a rasterized render. right? And so well, the biggest problem they had with that is that you couldn't do huge amounts of geometry. So they had developed a new system called brick maps in RenderMan that enabled them to do that. And sort of the optimal thing for brick maps is to create these voxel chunks of data, right? If you look at the trash heaps inside of Wally, they were
Right.
tailor-made for brick maps to make these boxes of things.
Got you. So
Okay.
they lent in, so they
So,
used
so
what the
they
capabilities
leaned
of the
into
stuff.
it, and
Right.
that
Nice.
literally the
Smart.
technology of what they developed to make it work became part of the story. Like literally, Wally was like a little box that made these little voxels that you could stack up. It was kind of brilliant and beautiful. So I always loved it. I mean, first of all, it's a brilliant movie, so let's not take away from the story, the beauty of what it is. But that was literally the problem they were doing. They were creating these little voxel things. So that became the solution, right? And essentially, by the way, brick maps back then is essentially what Nanite is today. They're trying to do the same thing, right? But eventually, when there people realize, like, well, you still have these limitations of what you can do with brick maps or whatever, but yes, you can do geometry. Eventually, they couldn't compete anymore. Once people started to look at full ray tracing, they couldn't do it anymore. So RenderMan was essentially forced to abandon their entire render that they developed for 30 years, right? Since the beginning of Toy Story and all these other things. They'd been developing that for some, they had to abandon their entire system of rendering and develop something completely new that was fully ray traced, which is what RenderMan is today, right? And so that's basically where we are. Eventually, all of these engines are going to be fully ray traced at some point if they're going to do
Yeah.
real time, right? Now, game engines don't need to be fully ray traced yet because they are for video games, and video games need to be faster speed, right? And so their motivation for rendering in a video game in a game engine should be for video games, right? So they're
Yeah.
going to
It's a
make their game,
priority. Yeah.
of
Right.
course.
Absolutely.
So they're going to make their game engine still rasterized. Fully ray traced is not a big priority. And when you can't ask your 13-year-old teenager can't demand their parents to buy them a 5090 to get a fully ray traced image on their game computer. It doesn't work, right? So you still have to go for the lowest common denominator
Yeah.
that
Yeah.
people
Yeah.
have. So I think that's sort of where those game engines are. They have to be sort of in that zone. But for high end stuff, for what we're doing in a film world, etc., full ray tracing totally makes sense. And there's another benefit to it that's beyond that I think is very, very important. And that is the fact that for post-production, for visual effects done in post, right? Those are always going to be fully ray traced because that is by far higher quality than you'd get in rasterization. We abandoned rasterization, like I said, back in 2006 for that very reason. But when you go fully ray traced, you kind of have to just abandon all of the other stuff. So when you do full ray tracing in visual effects, and you do full ray tracing in virtual production, you essentially can use the same asset for both.
Yeah.
You don't
Yeah.
need to have two
Absolutely.
pipelines, one for game engines and one for visual effects. You can have one pipeline and use the same asset for both. And that becomes
Which
a
for
big
for
game
a visual
changer.
effects heavy thing, it's like that is a very, very expensive and very time consuming as well, I imagine. Right.
Right. Or even previs. So like the thing that I'm sort of been pushing now is like people should realize like why build, we used to have this thing called previs, we had this thing called virtual production, and we have this thing called post-production, and all three of them are building the same asset three different ways. It's ridiculous. The producers are paying for the asset three times. Why don't they pay it for it once across the entire process?
Yeah, absolutely. You mentioned actually a bit earlier on about the use of cinematographers and lighting for sort of virtual production. What's your been experience of that? Because my experience is that it's that they not that they don't they find it challenging. It's just that actually a lot of them don't know where to start. I think there's a fear about that real time rendering, real time VFX, and who's responsible for doing what and what the capabilities of something are. Because a
That's an
cinema
excellent,
photographer.
excellent question. Well, let's look back a little bit. Again, let's go back to those, like I said, the Life of Pi days when everyone outside of visual effects hated it, and CGI, as they used to call it, was a dirty word, and everyone talked about how my movie doesn't use any of that CGI, and therefore my movie is better.
Yeah.
Right? I mean, that was the feeling. right? And I used to be very upset about that because I was like, it's taking away credit. They don't understand what they're talking about, et cetera. But when I really started looking at what they're doing, I've looked at what a DP and and a director were doing, when they were doing these giant Marvel films back in the 2015, 2018, whatever. They go into this giant blue room, right? They shoot a couple of people. They sort of imagine what the background is, and it still hasn't been figured out. They still haven't done anything. They're like, I don't know. I guess we'll hope for the best. We'll see it in 9 months. No wonder they hated CG, right? It was a
Yeah.
horrible experience. And they're basically completely lost control of the film. The DP had no control over the lighting, right? Nothing that was
No.
going on at all. And it was not their film anymore. It was some guy who came right out of, some visual effects school that's guessing what the DP wanted it to do and putting it into a film. And then that's not the right experience. So everything ended up, they would light everything very flat, right? Because that was the only way that like, I guess we don't need to care where the sun comes from because we don't know what the environment looks like. So they're like, everything was flat and dull and was just boring. And so of course it was a bad experience. So when you suddenly give them back their lighting, right? And when you look at in-camera VFX, or you do even what they were doing on Avatar or whatever, it's like the person can look through the frame and say, that's what I want, right?
Yeah.
And then it's not the responsibility of the lighter or the compositor to do it. It's the responsibility of the DP. And that's what it always should have
Which
been.
it should be, right? I mean,
Yes.
that's the
Right.
there's the word photography in it and director.
Absolutely. Right. And that's what it should be. So that I think is an important part of the process. I think where things get tricky, and I know things have changed a little bit, but in the early days of in-camera VFX, it was very, very hard to get something to look as real as ray tracing for your environments with real-time lighting. So a lot of times people would bake the lighting, right? They would look at the environment and you would bake the lighting into the environment. And that meant if you wanted to move the sun, you had to rebake the lighting and it would take
Yeah,
another
yeah, yeah. Oh,
day,
yeah. Been there,
right? That's
twiddling
again,
thumbs.
so this reminded me again. I always go back to the past of what I did. Right, I worked at Sony ages and ages ago, and they were still using a system called Burps at the time, which they definitely don't use now. But it was to be very honest, no fault of Sony. I think they're a fantastic company, but it was a horrible experience because the way there was such an old school mentality of how you did things. Again, it was a rasterized rendering. In order to move a light in Burps at that time, this is around 2003 or so. In order to move a light, you had to move the light and then send that to the render farm to re-render the shadow maps for that one light. So
Right.
people would avoid moving lights just because it was a pain in the ass, which is a very non-creative thing to do, right? So the same is true when you have to bake the lighting into your environment. It's like, yeah, you want to move the sun? Sorry, you're just gonna have to wait till tell us where you want it. We'll show you tomorrow. That's a horrible experience for a DP, right? But if you basically give them the system and you have full globalization done in real time all the time, and you can move your stuff everywhere, then the language of that light becomes much more native to the DP. They can speak to the person operating the system like they would any gaffer.
Yeah, yeah, yeah. Absolutely. Like a virtual gaffer. It's like, yeah, move that.
And that's exactly what it should be. And then
Yeah,
also they, because it's fully ray traced, they know we can use the same tools. You want to put a bounce card here, we can do it. You can do this, you
yeah,
can do that. And it's fully ray traced and it bounces off the system. And so we speak the same language as the DP. We even use the same lenses. We can even do the same lens distortion if necessary. That's ray tracing is much more of a closer analog or closer twin of the way the physical camera works because it's fully ray traced.
the penny dropped for me a couple of months ago. I was in the Netherlands doing a presentation, and I was talking to Wolfie. I'm trying to think of his surname. He's a DOP, and it's suddenly I've been toying. I've been trying to work out for the last 5 years the best definition for virtual production. Everyone's, someone came into the studio a couple of days ago and says, "Oh, can you do virtual production?" I says, "Well, what is virtual production in your mind?" Is, "Oh, well, it's a big LED wall, isn't it?" It's like, well, it's
No,
kind of, yeah, no, it's
it's
not,
one thing.
and it's a thing. It's a thing that's part of it, and actually what I've come down to is that virtual production is the ability for the creative team to direct real time. whether that's photography or whether that's action. In a match, you could, please move this. Yes, we can move that. If you can do it that, and it's not to your point, I mean, it's obviously got a bit quicker than having to send it off to the render farm and wait 24 hours before it came back. But, baking the light in was an absolute pain. You just stop all creativity while we just spend 5 minutes rendering this and baking it back in again. Oh no, I don't like that anyway. Can we move it halfway? And it's stop all creativity for the next 10 minutes. And then, but it's joyous when it works. The glee and the creative energy that suddenly comes up when the DOP realizes that they can move the sun and turn a light on and move this and put bounce cards in. And it's like this real new sort of sandpit, which is
Sure.
just a joyous thing to watch.
Yeah, absolutely. To me, it's interesting. You asked that question, what is virtual production? I think that's a great definition. To me, it's a little more technical. It's when you have your physical camera and your virtual camera doing the same thing at the same time, right? If you have a proxy of your camera so that the virtual world is captured the same way that the physical world is captured, that works. So that implies to, avatar-esque virtual production where you're looking through the monitor and looking into the virtual world through the monitor. Or if you're doing it in the virtual production or you're doing it on an in-camera VFX stage, the virtual world is represented on that LED wall and the camera that you're doing matches what you're doing that way. So that's the way I sort of define it.
Yeah.
But you're right. It's a way that essentially gives the creative tools back to the filmmakers in real time.
Yeah. I mean, that's what struck me.
Including the camera, which is the most important part.
Right. Someone said to me, virtual production is what would have been invented if you'd asked engineers to invent filmmaking. That's how they would have done it, which of course is actually what happened because the pandemic happened and engineers were asked to reinvent this process and it became
let's not fool ourselves. Virtual production had been around for 100 years. Right. I mean,
for sure. Yeah.
We were doing it was called rear projection. I mean, when you're looking at in-camera VFX, it's really just fancy rear projection. The only difference is that you can move the camera now. You couldn't do that before.
It's and hugely nuanced, et cetera, et cetera. And it suddenly struck me, it's like the virtual production of the broadcast world, which is all sort of multi-camera green screen. Broadcasting tends to be an engineering solution, whereas filmmaking is a creative thing, but creativity requires the fact that the director or the DOP are allowed to say, I don't like that shot. This isn't working. We need to do something differently. And if you can't turn around and says, oh, well, we're going to have to wait another 24 hours because we've got to or do something, or, oh, we didn't design the reverse of that shot. So we can't spin all the things around as well. So we're sort of running-ish out of time. This has been fun. So you mentioned SIGGRAPH. Are you going to there and some stuff that Chaos are going to be announcing, which you obviously I'm not expecting you to pre-announce the announcements.
Well, when does this podcast come out?
Oh, normally I edit it in a couple of days. So it'll be next week kind of thing.
Okay. So I won't tell you anything, but I'll tell you this. We're doing a lot of big advances that are going on. And I'll give you a flavor of what we're looking at.
Because then we can promote it, right? That's the thing.
Yeah. So a flavor of what we're trying to do is a lot of what you're going to see announced is going to be centered around the fact that we want to democratize a lot more virtual production to everyone and to every possibility. So right now, as you know, there's a lot of things that sort of force you into using a specific system. And therefore, once you get in there, you can't get out. Right. And so for us, we feel that we want to democratize it so that essentially any pipeline that you want to use would still allow you to get to virtual production and to be able to continue to use the same assets across multiple areas. So that basically we want to democratize virtual production to a much broader audience in a lot of big ways. So that's the first big thing we're doing. Also, another big thing that's happened in the world of virtual production is that there's been a misconception. We feel there's a misconception that virtual production is an extremely expensive thing to do for filmmaking.
Absolutely. Agreed.
Right. And I believe that there's a lot of ways that you can solve virtual production to make it significantly less expensive. What's been happening a lot of people, especially during the pandemic, right, when everyone was sort of looking at all these different ways of things, like we're going to solve filmmaking through virtual production, which is also a misconception. You're not going to solve filmmaking
Again,
through misconception. But there were a ton of people that just bought a bunch of LED walls and were hoping that they were going to open up stages and charge $50,000 to $100,000 a day and be rich.
right,
And
right.
that's
Guess what?
that didn't happen. But it doesn't necessarily mean that these stages are useless or that the technology isn't right. And so we feel that you can get your asset and get your things working on an LED stage for significantly less money. And that's one of the big things that we're developing with Arena, is being able to make that pipeline and make that accessibility to an LED wall much easier, right? So as an example, the way that Arena works, I can give you a little bit of an overview of that. This is not a secret. The way that Arena works is that it's based on V-Ray currently, right?
V-Ray's
V-Rays are
another
ray tracer. That's an
ray
offline renderer.
tracer in Chaos. Yeah, Chaos is one of them.
Chaos is Arena, but a V-Ray works in almost any 3D package. There's plugins for any 3D package, right? So if you're in Maya, you're in Max, you're in Houdini, you're in Blender, you're in SketchUp, you're in Rhino, we have V-Ray versions for all of those things, right? And then what you can do is, once you assign your shaders and have done your things that you want to do in that, then you can export a VR scene file from that thing and bring it right into Vantage, which is essentially the render that Arena works. And so therefore you can bring it right to Arena. So you can be from your application, doing your 3D thing, doing your modeling, doing whatever, export to wall immediately. Done. No
Right.
conversion, no worrying about does it work for real time, no changing your shaders to make it work for a game engine. You just go straight to the wall. And the idea is that you can make this translation happen very, very quickly. And that's, we say is like you can go from a Houdini scene to the wall in 10 minutes. Not
And
worry
so,
about it.
so just explain very briefly then actually what Arena is.
Sure. Arena. So I think I mentioned before, Vantage was our render that we do is specifically done for real time. And that came out of Project Lavina back in 2018 and became a standalone application that you can view your content that you've created in whatever application in a real-time window. And it was very, very powerful. People were using it to do quick previs. People are doing it to do live linking, because you can also do live linking. There's a lot of tools that people are using in Vantage. What we did for Arena is we've taken the Vantage system and we created it so that it scatters across multiple render nodes and created a camera tracking. So essentially, we've taken Vantage and made a end display version of it
Got
that
you.
works
Right. There we go.
for your wall, right? And that's
Right.
what Arena is. It's basically just wraps everything we do and puts it on the wall. But because V-Ray has been around for so long, right? It's coming up over 20 years, right? So there are tons and tons and tons of assets that are made with V-Ray, right? You can go on Turbo Squid or Evermotion or whatever. And in fact, we did this in the ray tracing for the wind thing. We needed a hacienda scene for the very last thing. And I just went onto Evermotion, downloaded an old scene that was 12 years old. Still looked
Right.
great. It was like a little
Yeah.
thing. It's like, cost me $100. Downloaded, put it up on the wall, done. Right. Never have to worry about it. Don't have to convert it to do anything. It's just done. Right. And then my DP is like, oh, can you make it sunset? Just move the sun here and there. Everything was working. It was done. It was so fast and so
Nice.
cheap.
And that's the democratization that you spoke
Right.
about. Is that, I mean, the democratization with Unreal Engine and some of the gaming engines is the fact that they are free. And, there's an awful lot of people who know how to build in them, but not that many people who know how to create film sets within them. They're great at building games.
Well, you can't model inside of Unreal, right? So you have to start with some other application.
Yeah.
And for us, we start with whatever that other application is.
Yeah.
So you don't have to. So a lot of times in those systems, and this is fine, right? A lot of times in those systems, you are sort of either you create something, convert it to work in the game engine and go through that whole painful process, or you buy an asset and you shove it in there, right? And so in the early days, if you look at the early days of virtual production with Unreal, everything looked like the Mars rover scenes because that's the only assets that were available on the store. It's a bunch of rocks.
Yeah. Well, yeah, there's an awful lot of haunted houses and, and other, spaceships. Guess what? That's what gaming is. All of those kinds of things. And I struggle when we're trying to do it. You look mainly in all the architectural visualization kind of library, because those are the things that in theory are going to look great or as good as they can do. So you're going to do that at SIGGRAPH, isn't it? It's called SIGGRAPH. Well, so when is SIGGRAPH?
SIGGRAPH is August 10th or 11th, I believe,
So we're
and it's in
talking
Vancouver.
3 weeks in Canada, which is quite exciting. That's good, and it's over a few days, and I imagine quite a few people from Chaos are going.
Yeah, we're going to be presenting a lot of stuff that's going on there. I mean, here's the thing, this is only really speaking from myself. Like, ray tracing is now, if you don't think about the real-time version of it, if you just think about ray tracing, it is now so good across everything that really almost essentially a saved problem. Uh,
Yes,
and
yes,
so the only thing that makes a ray tracer better, differentiates itself from other ray tracers, is how easy it is to get to where you want to be, how quickly
right,
you want to be, right? But for the
brilliant.
most part, they've pretty much solved problems. So now the next challenge, the next thing that's interesting to me in terms of ray tracing is, can you get it so it is fast enough to actually be real time? Right.
Got you.
And once you get to that real time, that really starts to change the way you think about things.
Yeah, that's game. Yeah, because there's that creativity side of things, right? The DOP and the director and the actors, they sort of get then that sort of instant
It's,
feedback. It's directable real-time VFX, which
I
I
just
think
think
will just be so exciting.
think about the old days. I mean, I've been in visual effects for a long time, where you sit there in a screening room, right? And you show your director the shots that you're working on. And they look at it and it's like, well, okay, this looks good, but we need to change that. That doesn't look this, that. It's like, okay, well, we'll see you next week and we'll show you the new version, right? It's
Right,
like a full week. And then you
right.
get to the next version. And you're sitting here sometimes months and months and months just going through version 5, version 10, version 20, version 100. And it's just, whatever it is. Really, what should be happening is you should be there. The director should like move it, and then you just moving it in real time until they say, no, 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 stop right there. That's it. When your finger comes off the mouse, that's when the decision is made, right?
Made.
Like that,
Yeah.
that should be the way it is. And that's way more interactive, right? As
And
opposed
that's
to,
yeah, and that's so. I mean, it is gleeful when you're able to do that. I did a hack shoot. I really it was quite funny, but it was. But I was that workflow was how we were working. I had the director and the DOP who were talking about move that slowly, move it a bit further back, give me a bit more blur, give me a depth field. That's it. So it wasn't technically accurate, but it was visually what they were happy and they were excited to actually take that shot in as well, which was brilliant. I've got a friend actually, he's on the group, Karim, and he invented and he just sort of did something a bit similar. He used Unreal Engine for 2D cartoons, so a bit like South Park. So a bit like South Park, just very, very basic sort of walking. And you flip round, and he can control it with an Xbox controller
awesome.
and a camera. So
Right.
he talks, and it's real time animation. So a director can say, "Oh no, keep going, talk a bit more. This is the script."
Right.
It's like this everything. I mean, there's a big lean in because there's so much more forgiving in that format.
Right.
But it's the same process. It's like this ability to just be able to go, "I'm going to walk the dog over here," and he's going to say hello, and
And
it's like,
honestly, that is what I think game engines are so cool at, is you can create these interactive experiences that work so well, right? And I think this is an important part that I think I want to distinguish, because I do not believe that, game engines are not necessarily a solution. I just don't think they're always the solution for what you need, right?
oh,
For
yeah,
that is a great example of the interactivity that you can program into the game engine that allows you to happen. That's what it is, right? It's the game engine is to make games, right? And
yeah,
that's what it does.
yes.
But if all you need, I'm just saying all you need, if what you need is a photoreal background that's correct and matches your environment, we can get there much faster and much cheaper.
Yeah, 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 yeah. Because
And,
however you sort of hack it. It's a bit to your point earlier on about this sort of mentality when you first started about hacking all of these things to avoid ray tracing, and
right,
that sort of feels a bit similar to the thing what's going on with the gaming engine at the moment. There are so many hacks. Gaussian splatting. Oh, you can do Gaussian splatting. It's great. Looks brilliant. Well, yeah, but you can't move this. You can't move any lighting. It's all, or you can't really change. I mean, you can change the camera. Well, then it all goes a bit funny. Still, it's not really production kind of stuff as well. So these are sort of all these little hacks, which again, I think to your point, it's like some of it's democratizing, and then also maybe it opens up the creativity about the art of the possible. in
Right.
itself as well, which, the types of things that you're developing, as you say, it's like it's going to get faster, cheaper, and easier to use, isn't it? Because
Yeah, and
that's what
there's
happens.
several things that are important, right? And I mean, we mentioned democratization, whatever, and democratization. I want people to realize, like, that doesn't necessarily mean free. Doesn't mean it's democratized, right?
No, no, not at all. No.
But I think what free means is that it means it's accessible to a lot of people. When things become democratized, it's when it becomes much simpler and faster for people to do things. And the language is interesting, right? And if you have a DP, especially if you have, like, the DP we worked on ray tracing for the win, and I'm still working with him today because he's a great guy. But he comes from old school DP, right? He trained under Gordon Willis, Gordon Willis shot The Godfather, right? And so Richard really understands the fundamentals of a camera, of what it's supposed to do, right?
Yeah.
He understands color, he understands science, he understands composition, he understands how lighting works. And when I gave him access to the full ray tracer, the analogy that it is of the real world just works, right? It's
Right.
the same language.
Yeah.
And so therefore the conversation you're having between the DP and the digital gaffer, as they're calling it, is the same conversation he's having with the physical.
Right. And you're not having to have some sort of translator in between
No.
going, what's a nanite? What's this? Why is
Yeah,
that?
yeah.
Why
No,
can't you
I
move it
gotta
this way?
redo this, and I gotta rebake this, and I gotta
Yeah.
So it just becomes much more like, no, I just do this,
Yeah.
and it
Which,
becomes
yeah,
much
I think
easier.
Chris, it's been an absolute pleasure. Thank you so much. Thank you for being patient as well at the beginning. And thank you for sort of sharing so much knowledge. That's amazing. Was there anything else? Are you up to anything else? You writing a book or?
No, I'm not writing a book. The thing is, I am still very, very passionate about this, both the technology and the art of filmmaking. So I'm still very much working in the filmmaking thing. The part of the joys of working in a lab is I get to try all kinds of new technology. I would say, look out for what we're going to be doing at SIGGRAPH. There's going to be some press releases. There's going to be some interesting things going on. So definitely pay attention. And that's going to be in a few weeks.
Brilliant.
Excited when it becomes public and I can talk about it a
As
little bit
well.
more.
Thank you again so much. And and I'm sure we'll have other times to talk in the not too distant future.
Sounds great, Rob. Thank you so much.
Well, before you go, have you come across, have you met David Wright from NVIDIA?
David Wright? I don't know if I
Yeah.
know David. I know a lot of people in
Uh,
NVIDIA, but I don't know about David.
he used to work for the big boss. That's just, I wondered if you'd come across him. That was all. He weirdly happens to be my partner's sister's new partner. And it was only
Wow.
the fact that we bumped literally, and no one's in the business. And it's like, and now we talk now and again about certain bits and pieces. And it's just weird how sort of these connected dots almost, freakily happening. Anyway, thank you again. Thank you so much. And
Thank
I'm
you
sure
so
we'll talk
much.
again. All right.
All right. Have a
Take
good one.
care.
Bye.
Yeah, you too. Bye.